From self-driving cars to advanced search algorithms, machine learning is everywhere. Today, we are going to focus on a machine learning algorithm called least squares. Let's say you're bored in quarantine, so you decided to embark on a 2-week push-up challenge. The data shows the number of push-ups you did throughout this challenge. The general trend is, as the days increase, the number of push-ups also increases. Now we can estimate that this line seems to fit about right, but how do we find the optimal line that fits the model? In this example, we can change the slope and intercept parameters. Let's start with a horizontal line to represent the trend of our data. We can calculate the differences between the observed values, or the points, and the predicted value, or the line. These differences are known as residuals, and they're nothing but the observed value y minus the predicted value denoted by y with a hat. However, the residuals on the bottom are negative, so we need to square these values. To find the goodness of fit, or how well the line fits the model, we simply add up the residuals to get the sum of the squared residuals. The closer the sum is to 0, the better the fit. The horizontal line at first glance doesn't seem to be the best fit. In fact, the sum of the squared residuals is far from 0. If we change the slope, recalculate the residuals, and add them up, we get 203.26. We can keep doing this to get closer and closer to 0. However, if we rotate the line too far, the values start going back up. If we plot the sum of the squared residuals with the rotation of each line, we can see that the SSR values start off big, come down, and go back up again in the shape of a parabola, similar to our data. We can use gradient descent to find the lowest value in our function to minimize error. To better understand this, imagine being blindfolded on top of a cliff trying to reach the lowest ground. You would make your way down the incline, and when the slope starts going back up, you would take a couple steps backwards to reach the lowest point. The same applies to the parabola, where we can start our descent from a random point. Taking the derivative of the point gets us the slope of the function at that position. This tells us how steep the incline down the mountain is. The slope is very steep at this point, so we know that this is not the lowest point. Now we need to descend further down the parabola and try again. The amount that we go down the parabola each time is known as the learning rate, and it gets smaller and smaller down the parabola. This is similar to the step size on the mountain. We can continue this process till we get closer and closer to the lowest value. The slope here is the closest to 0, since it's a horizontal line, so we have found the minimum of the function and reached the lowest point in the mountain. Therefore, we can conclude that this line is the best fit for our model. And using least squares, we can predict the number of push-ups you can do in a week or even month.